Hello, this is the second video for section 9.2. So remember, we're solving these equations by completing the square. Just go and fix the little typo here. This should just say x squared minus 16x equal to negative 16. So I need to take half of that middle term, square it, get negative 8 squared, which is 64. So I'm going to add 64 to both sides of this equation. We get x squared minus 16x plus 64 equal to 48. That then factors as x minus 8 squared equals 48. Take the square root of both sides. You get the absolute value of x minus 8. And then you could do a factor tree to simplify this, remember. I'm just going to use the fact that I know it's 16 times 3. So then I get x minus 8 is equal to 4 square root of 3. Or x minus 8 is equal to negative 4 square root of 3. And then add 8 to both sides of both equations to give us the final two solutions of x equals 8 plus 4 square root of 3, or x equals 8 minus 4 square root of 3. Don't make the mistake of combining the 8s and 4s, because remember the square root of 3, they are not like terms. Part F, x squared plus 10x plus 4 equals 15. First thing we're going to do before I complete the square, just because that 4 is kind of in the way, is I'm going to subtract it from both sides. So then x squared plus 10x is equal to 11. And then in part B, we already did an x squared plus 10x, so I know I need to add 25 to both sides. So we get x squared plus 10x plus 25 is equal to 36, which then factors as x plus 5 squared equals 36. Take the square root of both sides. We get x plus absolute value of x plus 5 is equal to 6, which means x plus 5 is equal to 6, or x plus 5 is equal to negative 6. Then subtract 5 from both sides of both equations, and it gives us the final solutions of x equals 1, or x equals negative 11. Part G, we are missing the equals 0 part. So just like in the previous part, I am going to subtract that 11 so that my variables are by themselves. So we get n squared plus 3n is equal to negative 11. I then need to take half of that middle term and square it, which is 3 halves squared, which is 9 fourths. So I'm going to add 9 fourths to both sides. We get n squared plus 3n plus 9 fourths is equal to negative 35 fourths. The left-hand side then factors as n plus, and don't forget, it's going to be that term, so n plus 3 halves squared is equal to negative 35 fourths. Take the square root of both sides. We get the absolute value of n plus 3 halves is equal to I square root of 35 over 2. So I took the square root of the 4, that's why my denominator became a 2, and 35 cannot be simplified, but because it was negative, we get an I in our solution. So we get m plus 3 halves equals I square root of 35 over 2, or m plus 3 halves equals negative I square root of 35 over 2. Subtract 3 halves from both sides of both equations. Thankfully, the fractions have a common denominator, so our final solutions are n equals negative 3 plus I square root of 35 over 2, or negative 3 minus I square root of 35 all over 2. And now part H, we have x minus 3 times x plus 5 is equal to 9. Well, we actually can't use factoring techniques because it's not equal to 0. And we also can't complete the square as is because we don't have x squared. So the first thing we have to do is distribute out this left-hand side. So we get x squared plus 5x minus 3x minus 15 is equal to 9. And now, just like in the previous two parts, I want to get rid of that constant. So I'm going to add 15 to both sides. So we get x squared plus 2x equals to 24. Now, what do I need to add to complete the square here? So I need half of 2 squared, which is 1 squared, which is 1. So I'm going to add 1 to both sides of this equation. Get x squared plus 2x plus 1 is equal to 25. X plus 1 squared is equal to 25. Take the square root of both sides. Absolute value of x plus 1 is equal to 5. We get x plus 1 is equal to 5, or x plus 1 is equal to negative 5. Subtract 1 from both sides of both equations, and we get x is equal to 4, or negative 6. To solve by completing the square when the quadratic is of the form ax squared plus bx plus c equals 0, we have to divide through by a so that the leading coefficient is 1, and then we can use the same strategy as above. So in other words, the coefficient of the squared variable always has to equal 1. So example 5, solve by completing the square. Well, the first thing I'm going to do is add that 15, because I can't have that on the same side as the variables. And then I'm going to divide by 3 on both sides. And we get x squared minus 4x equals 5. And now we can go about completing the square like we did in the previous examples. So half of negative 4 squared is negative 2 squared, which is 4. So add 4 to both sides. We get x squared minus 4x plus 4 is equal to 9. The left side factors is x minus 2 squared is equal to 9. Take the square root of both sides. We get x minus 2 absolute value is equal to 3. So x minus 2 equals 3, or x minus 2 equals negative 3. Add 2 to both sides. We get x equals 5, or x equals negative 1. Part B. So following the same steps, subtract that 14 first, because you want the constant on the other side. And then divide by that leading coefficient of 2, and gives us the equation m squared plus 8m is equal to negative 7. So now I need to take half of 8 squared, which is 4 squared, or 16. So I'm going to add 16 to both sides of this equation. Get m squared plus 8m plus 16 is equal to 9. Sorry. Then that factors into m plus 4 squared equals to 9. Take the square root of both sides. Absolute value of m plus 4 is equal to 3. M plus 4 is equal to 3. Or m plus 4 is equal to negative 3. Subtract 4 from both sides. We get m equal to negative 1, or m is equal to negative 7. Part C. 3x squared plus 2x equals 4. Now, we were lucky in the last two problems where dividing by a didn't give us fractions. That's not going to be true anymore. So we need to divide by 3 on both sides. And we get x squared plus 2/3 x equals 4/3. Now I need to take half of that middle term squared. which is 1/3 squared, which is 1/9. So I'm going to add 1/9 to both sides. So we get x squared plus 2/3 x plus 1/9 is equal to 13/9. Factor the left-hand side, it's x plus 1/3 squared. Again, using this term from my previous work, is equal to 13/9. Take the square root of both sides. Get the absolute value of x plus 1/3 is equal to the square root of 13 over 3. So we get x plus 1/3 is equal to the square root of 13 over 3, or x plus 1/3 is equal to the negative square root of 13 over 3. And then subtract 1/3 from both sides of both equations. And thankfully, all the fractions have a common denominator, so we get x equals -1 plus square root of 13 over 3, or x equals -1 minus square root of 13 over 3. And then the last example. So we need to divide by 3 again on both sides. We get r squared minus 2/3 r equals 7. So I need half of -2/3 squared, which is -1/3 squared, which is 1/9. So add 1/9 to both sides of the equation. We get r squared minus 2/3 r plus 1/9 is equal to 64/9. We get r minus 1/3 squared equals 64/9. Take the square root of both sides. We get the absolute value of r minus 1/3 is equal to 8/3. So r minus 1/3 equals 8/3, or r minus 1/3 equals -8/3. Add 1/3 to both sides of both equations. We get r equals 9/3, or 3 for the first one, and we get r equals -7/3 for the second answer. And that is it for section 9.2.